So all clear. Is my screen visible? Is the screen visible?
Yeah, visible.
Yeah, so yesterday we had seen whenever this prefix will goes down, router 1 will generate one query message, right? This time router 2 will not generate reply until and unless router 2 will not receive reply from their another neighbor. Router 2 have one more neighbor, that is router 3. So once router 2 will receive query from router 1, it will send acknowledgement. This is query message. This is acknowledgement message, and it will send query message to their another neighbor, router number 3. Router 3 will send acknowledgement. If router 3 has another neighbor, then they will forward query to another neighbor, right? And router 1 is waiting for reply. And in this time, this prefix, state of this prefix is active, right? So whenever router will send a query message, it will start a timer, active timer. That is by default 180 seconds. We can change it. Now guys, if router 1 will not receive a reply message within half interval of active time, half interval means 19 seconds. So after 19 seconds, router is going to send one more query message. That query message is SIA query message. What is the purpose of SIA? SIA stands for stuck in active state. What is the purpose of SIA query? Purpose is now router 1 is asking to router number 2, bro, I had sent you one query just 90 seconds before. I'm waiting for reply. Are you working on my query or not? Right? So router 2 will generate what? SIA reply. SIA reply that yes, I am working on your query. Once router 1 will receive this SIA message, it will reset the timer. Again, it will set time to 180 second. Again, after 90 second, it will send one SIA query. Again, it will receive the SIA reply. It will reset the timer. So router 1 is going to actually send 4 SIA query. After that, router 1 will break the neighborship adjacency. It will not break neighborship adjacency after 80 seconds. This is the new concept. So if the main query message is clear, then you can understand this one also, SIA query. And this is the reason only why I have not covered this in last class. Just I wanted to give you some time, right, to understand the query. So whenever a route will goes down and feasible successor is not available for that prefix, then router will generate query message. Guys, there are two states of prefix in EIGRP. One is passive, one is active. Passive means stable. Stable means there is successor for this network and everything is working fine. And active state means unstable, right? It is asking to their neighbor for the alternate path. Active and passive. So by default, if EIGRP topology is stable, then state of all prefixes will be passive, right? Now guys, if interviewer is going to ask you what is SIA, stuck in active state, how you will explain? Tell me, anyone try to explain what is SIA? Right? And in the same way interviewer will ask the question, right? Interview is not going to ask you what is EIGRP, what is the AD value of EIGRP, what is the multicast address. He is going to ask you these questions. What is SIA? What is SIA query? When router will generate query message? How to reduce the number of query or scope of query? What is the solution of SIA? These can be the questions in interview from EIGRP protocol. So tell me, what is SIA? Hello? Please try. Okay, tell me the process. Can anyone tell me the process? Okay, tell me. Second thing, is it good thing or bad thing? SI is good thing or bad thing?
Bad.
Bad. It is an issue.
Bad.
It is an issue because there is chance that routers are going to break neighborship adjacency. If router will break the neighborship adjacency, performance will reduce on the router, and users will start getting slowness, packet loss. So this is issue in EIGRP. And 180 second is long time. So you can say SIE means EIGRP is trying to find new path, or SI is asking for the alternate path to neighbor, right? Whenever successor will goes down, router will ask for the another successor alternate path to their neighbor. That time router is going to put that prefix in active state, and that situation is called SIA, which can drop the EIGRP neighborship adjacency, which will reduce the performance. Right? Sometimes they can ask you like what is active also, what is active state, what is passive state. So passive state means router knows the best path for the destination and everything is working fine. When a route goes in active state, it means router has lost the successor best path to reach destination, and it is asking for alternate path to neighbor. Passive can be, you can say passive state means stable, and successor is noun. Active state means unstable. Router is looking for alternate path by sending query packet to their neighbor. All types of packet message should be clear to you in EIGRP, like hello to acknowledgement. Done. Okay, query message is unicast message or multicast message?
Multicast.
Multicast. Right. But guys, SIA query message is unicast or multicast? How I can check the SIA query message? I can do one thing. I can apply ACL on router number 3 over here. Right. So whenever this prefix will goes down, router 1 will generate query. It will send query to router number 2. Router 2 will send query to router number 3, and until and unless router 3 will not generate reply, router 2 will not generate reply to router number 1. So after 90 seconds, router 1 is going to send SIA query. So we can capture the link between router 1 and router 2. Capture the link and let me enable the EIGRP very quickly on all the router. To enable EIGRP, so IP interface brief config t interface f0/0 no set and IP address 12.1.1.1 255.255.255.0 exit interface loopback 1 IP address 192.168.1.1 255.255.255.0 exit router EIGRPS number 10 and network 0.0.0 config interface F0/0 no set IP address 12.1.1.2 255.255.255.0 interface F0/1 no set and IP address 23.1.1.1 255.255.255.0 router EIGRPS number 10 and network 0.0.0 interface F0/0 no set and IP address 23.1.1.2 255.255.255.0 I'm running /24 you can configure /30 as well no problem 2.1 255.255.255.0 exit router EIGRPS number 10 and network 0.0.0 so IP route EIGRP so I'm running this subnet 192.168.1.0 correct and in the capturing you can see routers are exchanging hello message update message of router 2 and the acknowledgement from router number 1 fine now on router number 3 I am going to configure one ACL and before configuring the ACL what I have to do I have to increase the hold on time otherwise EIGRP neighbors will goes down where I'm getting duplex mismatch error F0/0 router sorry interface F0/0 how to increase the hold on time guys IP hold on time for EIGRPS number 10 65535 on router number 1 also router interface F0/0 IP hold on time for EIGRPS number 10 65535 on router number 2 interface range F0/0 and F0/1 IP hold on time for EIGRPS number 10 65535 now on R3 access list 100 deny EIGRP from source any destination any and access list 100 permit IP any rest all traffics are permit now interface F0/0 IP access group 100 direction in applied the ACL so IP EIGRP topology 192.168.1.0/24 state is passive and so IP EIGRP neighborship is up q count is 0 now see the capturing on router number 1 I am going to down loopback interface loopback 1 says shutdown here is the query message on multicast address 224.0.0.10 and in the query message you can check the delay for this prefix not for 12 for this prefix delay is metric delay is maximum now here we need to find SIA query message so before that so IP EIGRP topology. Here state is active, and so IP EIGRP neighbor. Guys, this time Q count is still 0, right? Because it is receiving acknowledgement from their neighbor, from router number 2. Now somewhere we'll see the SIA query message. .12.1 query acknowledgement from 12.2, query from 12.22 for their neighbor, acknowledgement from router number 1. Fine. Here see SIA query. Are you able to see SIA query, guys? Is it unicast or multicast?
Unicast.
It is unicast. Why it is unicast? Again, same concept. Let's say router 1 is connected with 2 router switch, then R2 and R3. So if this prefix will goes down, router will generate query message on multicast address, which will forward to both. Let's say router 2 have given the reply message, right? Have sent the reply message. Router 1 have received reply message from router number 2, but it have not received reply from router number 3 only. So this time, after 90 seconds, router 1 is going to send SIA query only to router number 3, not to router number 2. So that's why it is sending on unicast address. If it will send SIA query message on multicast address, then router 2 will also receive SIA query, right? And here you can check the opcode value as well of all the messages. So today we covered 2 mode messages in EIGRP. One is SIA query and another one is SIA reply, right? So total number of messages in EIGRP is hello, update, query, reply, acknowledgement, SIA query, SIA reply, 7. By the way, these are the part of query and reply message only. SIA query is nothing but the part of query message only. So we are saying 5 types of message in EIGRP. You can say 7 also, 5 also. After that, see reply message. Quickly router 2 have sent the reply message, and once router 2 will send SIA reply message, router 1 will reset the time. It will reset the timer. In SIA query message, what informations are there? Subnet, destination network, and scale delay, next hop, for self advertised prefix, hop count. Okay, same informations are there. Then guys, in the reply message also, delay is maximum. That means router, their neighbor also don't have alternate path. Now after 90 seconds, router 1 will send one more SIA query message. So where is the next SIA query message? Router 2 is sending this query message. In the GNS3 you will not get exact output, but what I told you, router 1 will send 4 number of SIA query message, 4 number of SIA query message. After that it will break EIGRP neighborship adjacency, so IP EIGRP topology. So now you can see it have removed this prefix from topology table. So IP EIGRP neighbor, and again it have formed the neighborship with router number 2. Right. So SIA query and SIA reply. Hope this concept is also clear to all. interface loopback 1 no set. Guys, when this network will come up, which message router 1 will send to router 2? Which message it will send?
Update.
Update message. And router 2 will send acknowledgement. Right? First of all, whenever any change will occur on the router, like change means whenever new prefix will come up or any prefix will goes down, first thing is router is going to increment in sequence number by 1. It will increase their sequence number by 1. So that's why for all neighbor, you can see in the neighbor table we are able to see the sequence number. These are very important for troubleshooting. EIGRP neighbor. For this particular neighbor 12.2, sequence number is 19. Means router 1 have received updated information from this neighbor with sequence number 19. Right? So if router 1 will receive any update message from this neighbor 12.2 with higher sequence number, then only it will check. That means there is some new information, updated information are there in the update message.
So if router 1 goes down and come up, sequence number will be the same or 0?
0.
And sir, how many times it will send SIA query and up
4
to what
times
time?
4 SIA query.
After 90 seconds, na, sir?
Total after 360 second routers will break the neighborship. After 360 second, it will send 4 SIA query.
And
Got
sir,
it?
in 180 in case of acknowledgement.
In case of acknowledgement, router will send 16 unicast update message. 16 unicast update message. Now guys, we can do one thing here. Solution is, see, first router should not generate query message. This is one solution. We can add the feasible successor. We can perform summarization. We can configure the stub router. Soon we are going to discuss stub router as well. The next thing is we can disable the stuck inactive state. Means if router 1 have sent the query message, it will be waiting for the reply for lifetime, but it will not break the neighborship. Right? Router EIGRP yes number 10. Timer active time, and see you have one option to disable. You can change the timer as well if you want to increase or decrease. Right? Like if because of query message neighborship is fluctuating between router 1 router 2, what we can do, we can increase the time. If router 1 is receiving reply message, let's say after 500 seconds, so we can configure this timer 600 seconds, or we can disable it. We can disable it. Disable. So IP EIGRP topology 192 not there. Interface loopback 1 no set, and so IP EIGRP topology. What happened? Okay. State passive. Again I am going to down loopback 1, say shut down. So IP EIGRP neighbor, so IP EIGRP topology. It have removed the prefix. The reason guys, I think neighborship is down between router 2 and router 3. So that's why router 2 is directly generating the reply message. So here we can verify that. So IP EIGRP neighbor. Yeah, we have neighborship with 23.2. Okay, we have disabled the feature stuck inactive. So this is one solution. And guys, the next solution is stub router in hub and spoke topology. In hub and spoke topology, what we can do, we can configure a stub router. Now from router number 3, I am going to remove the ACL. Do so IP route EIGRP. Actually it is learning this prefix, but I think router 1 is not learning. So IP route EIGRP, you can see. So IP route EIGRP, we don't have 192.168.2.0 because of access control list. So interface F0/0, no. IP access group 100 direction in, removed it. Even I can remove the access list, no. Access list 100. Now again let me check routing table. Now you can see we are learning this prefix, so it can communicate ping 192.168.2.1 and source 192.168.1.1. Source 192.168.1.1. Where is the issue? So IP interface brief, I think loopback interface is down. Yes. So interface loopback 1 no set. And now you can check ping from this source. Source working, right? Means these two LAN are able to communicate with each other. Now guys, I am going to close this topology because this topology is not required now. We are going to create another topology here. GNS3. This time I am going to create hub and spoke topology. Somewhere you can write down the, in your notebook, like the complete process of query and reply. Complete process of query and reply. In step 1 you can say step 1. Step 1. When route bill goes down, router will generate query message. Or you can say when router will lose the successor for the destination prefix, it will generate a query message if feasible successor is not available, and it will put that route into the active state. In step 2, what will happen?
To generate the query message.
Yes. Then step 3.
In step 1, sir, we can also add that it will check for backup path. If there is no backup path, then it will
I already
generate
told
query
you now,
message.
whenever router lost its successor to the destination and router don't have feasible successor or backup path, then it will put that prefix in active state and it will generate query message to
Sir,
their
it will
all,
generate
all
query,
neighbor.
yes, on the multicast address.
Yes. Asking if they have any alternate path. Once neighbor router will receive the query message, neighbor router will generate reply. Right? If the router will not receive reply, then after 90 seconds it will send SIA query message. Right? Once router will receive reply, SIA reply message, it will reset the timer. Like this, router will send 4 number of SIA query and then it will break the neighborship adjacency. This is the complete process. The verification command is show IP EIGRP topology. You can use to check the state. And I have shown you the command to change timer as well and to disable stuck in active state also. Now stub router.
So what is the purpose of SIE update that router is sending?
SI update. Where is SI update message?
Reply, sorry.
SI
SIE
reply.
reply.
So what is the purpose of SI query?
Who ask for the alternate route for that?
No. Who told you?
Oh, sorry. SIE query to means if.
Miss, are you working on my query message? I had
Okay.
sent you the query message. Are you still working on it? Router will generate reply message. I reply, yes, I am working on it. I have sent the query to my neighbor. I am waiting for the reply.
Okay.
Now guys, what is stub router? Stub router is a way to avoid the SIA issue in large EIGRP network. In EIGRP network, to avoid SIE issue, we have a feature called stub. Got it? If you will configure a router as a stub router, then that router will not generate query message. Stub router will only advertise connected prefix. Means I am the edge router, right? Like guys, I have a topology R1 in hub and spoke R1, R2 and R3. And like this we can have multiple spoke. If you have 2 side, 100 side, then 100 edge routers are there. Three switch hub router, spoke 1, spoke 2. So spoke are what? Edge routers, right? Means R2 is going to advertise which prefix to router number 1, guys. They are directly connected network 20.1.1.0/24, 20.1.2.0/24. Router 2 will only advertise their directly connected network. Router 2 is not transit router. Means router 2 will not advertise any prefix, any received prefix to router number 1 to hub router, right? Like router 2 is not connected with any other router. So router 2 should not receive any query because router 2 cannot resolve the query, yes or no, because it is edge router. Router 2 is edge router. In the same way, router 3 is edge router. Router 2 and router 3 spoke routers will only advertise their directly connected network. /24. But if I will talk about the router 1, guys, router 1 is going to advertise their on prefix as well as branch 1 spoke 1 prefix to spoke 2 and spoke 2 prefix to spoke 1. Yes or no? So R1 is not edge router. Edge router means the last router. Getting my point? So should router 1, whenever like this prefix will goes down, should router 1 generate query to router number 2? No, because router 2 will already told to router number 1 that bro, I am edge router, I have only connected prefix, I am only advertising this connected prefix, so never send query to me. Never send query to me. Transit router means, see, yesterday also I have given this example R2, R3. Here I have one network X network, here I have one network Y network. So R1 is responsible to forward traffic in X network also and in Y network also. Y network is not connected with router number 1, not connected, right? It will learn Y network from router number 2. Means router 1 is forwarding traffic of other routers as well. So that's why we are seeing router 1 is the transit router. So transit router should not be configured as a stub. Which router should configure as a stub? Edge router. Got it? Here also you can see that. Here is the transit point. What is the meaning of transit point? A transit point in a network refer to a router or device that forward data packet between other routers or network. Like your R2 in this scenario. R3, here X, here Y subnet. So R2 is responsible to forward traffic in X network, which is the network of another router, and Y network, which is again network of another router. Data packet between other routers or network. When a router is a transit router, it involved in routing traffic that originate from another router or network and it destined for another router or network. This means the router is not just handling traffic for its directly connected network, but it also for other part of the network, enabling end-to-end communication across multiple network segments. R1 is connected to R2, R2 is connected to R3, R3 is connected to R2. What it's saying now? If a device connected to R1 want to communicate with a device connected to R3, the data packet would travel from R1 to R3 via R2. In this scenario, R2 act as an transit point because it forward data packet between router 1 and router 3. So which router should be a stub router here?
Sir, R3.
Hmm?
Sir, does as router does not work in AS system? It is not. It is not part of AS.
It is part of ES only. EIGRP work within ES only. What I am saying that there are two types of router. One is edge router, another one is transit router. Edge router are the router which is responsible to forward traffic to connected network, and transit router is the router which is responsible to forward traffic to connected network as well as indirectly connected network. So your edge router should be configured as a stub. So if I will configure R1 as a stub router, right, then router 2 is not going to send any query message to router number 1, because router 2 no, this is the edge router, right? Router 1 have only X network information. Same thing here I am saying. If the device connected to R1 want to communicate with device connected to R3, the data packet would travel from R1 to R3 via R2. In this scenario, R2 act as a transit point because it forward data between router 1 and router 3. Transit router and edge router. Transit router, a router that forward traffic between other routers or network. In your example, R2 is transit router because it forward traffic between router 1 and router 3. Edge router, a router located at the boundary of network that connect internal network to external network. Edge routers typically manage traffic entering and leaving the network, but do not forward traffic between other routers within the network. In your example, R1 and R3 can be considered as edge router. So I'm going to design this topology here in GNS3 now. It is in India, it is in Australia. We have one prefix in New York, headquarter, hub router. Benefit of stub configuration, reduced query traffic. See the topology first. Where is R1, R2, R3? The common subnet and network on router number 1 in headquarter, in branch 1 and branch 2. And now read this. When R2 and R3 are configured as a stub router, they will not receive query message for network they do not know about. This reduces unnecessary query traffic across the WAN link, which is beneficial over long distance like between New York, India and Australia. So by default, if you will not configure the stub router, guys, router 1, whenever any prefix will goes down, whenever change will occur, right, if this prefix will goes down or this prefix will goes down, what will happen? It will generate query to the hub router, because here we have only neighborship. This is hub and spoke topology. Here we don't have any neighborship. And once router 1 will receive query message from spoke 2 from router number 3, it will send query to router number 2, and it is router 3 is waiting for the reply. So it might be possible, see, the all routers are in different country, right? This is in New York headquarter, this is in India. From India, one router is sending query to New York, the New York router is going to send query to Australia, and if New York router will not receive query from the Australia, then it will not generate reply, it will not send reply to router number 3. Might be possible that router can break the adjacency. After 360 seconds, it will break the neighborship adjacency. So guys, if you have only 3 sites, then no problem. But just imagine if there are 1000 number of branches. If there are 1000 number of branches, then performance will reduce. So that's why here we should configure a stub router to avoid the query. So configuring a stub router can improve network stability, reduce query traffic, optimized bandwidth usage, simplify configuration. How I am saying optimize bandwidth usage. WAN link between New York and spoke locations are likely to have limited bandwidth compared to internal networks, internal link. By reducing the amount of routing information exchange like your update message, query message, we can save the bandwidth, actual bandwidth. So whatever bandwidth you have here on the WAN link, right, you are paying to ISP. So you will have less bandwidth. Definitely you have to take care about the WAN link. Done. Now guys, see how to configure it. So in GNS3, let me say hub and spoke because we'll use same topology in OSPF also. R1, R2 and R3. I'm going to use one switch. This switch is nothing but the internet. Even you can change the logo of this device. In real time, you will have public IP address on WAN link on the WAN port at each side, and all public IP address will be reachable with each other. Here I am using switch for the reachability. Now if you are thinking how we can configure EIGRP here, Praful, because these routers are not directly connected. Yes or no? Guys, inside the ISP network there will there will be lots of routers. So can we configure EIGRP between undirectly connected routers? No. EIGRP works within connected router. So what we will do, guys, we'll configure VPN here, right? You can say EIGRP works on same subnet only. So in real time here at each side you will have public IP address. Let's say here IP address is 1.1.1.1. Here IP address is 2.2.2.1. Here IP address is 3.3.3.1. Right? So we cannot form EIGRP neighborship between 1.1.1.1 and 2.2.2.1. EIGRP work on same subnet. So with the help of these two public IP address, first we are going to create one virtual private network here, VPN, right? And on the VPN we will configure EIGRP, right? Don't worry, we'll see that the VPN configuration and those all things later. For now, you can assume that all routers are directly connected with each other, and we have the common subnet here, that is 192.168.1.0/24. I will configure .1 on router number 2, .2 on router number 2, and .3 on router number 3. On router number 1, I have some subnet 10.1.1.0/24 and 10.1.2.0/24. On router number 2 also I have some subnet 20.1.1.0 and 20.1.2.0, and on router number 3 also I have some prefix 30.1.1.0, 30.1.1.2.0. Guys, two things we are going to understand here. One, EIGRP static neighborship, because in the dynamic neighborship all routers are going to form EIGRP neighbor with each other. Here also we will have EIGRP neighborship. Here also we will have EIGRP neighborship. Here also we will have EIGRP neighborship. But I don't want to form EIGRP neighborship between router 2 and router 3. What can be the reason? For the better performance, guys, right? Like if there are 100 branch side, then this router will have how many EIGRP neighbor? 101, right? So to reduce EIGRP adjacency, we can configure hub and spoke topology here, right? This is my hub router, headquarter, and these are the spoke. spoke 1 and spoke 2. Done. Now let's begin the configuration. I am going to use Notepad for the configuration. On router 1, config T, then interface F0/0, no cert, and IP address 192.168.1.1.255.255.255.0, exit, interface loopback 1, IP address 10.1.1.1.255.255.255.0, and loopback 2 10.1.2.0. Then we need to enable EIGRP here. So say exit router EIGRP ES number 10 and network. Let me use 0.0.0. Correct. This is the configuration of router 1. Copy and let me paste it on R1. Paste. Done, guys. On router number 2, IP on F0/0 is going to be 192.168.1.2 on loopback 1, 20.1 on loopback 2, 20.1.2.1. Copy and paste on router 2. Then router 3, 30.1.1.1, 30.1.2.1. Copy and paste on R3. Done. So now see on router number 1, let's verify the configuration from R1. On R1, show IP EIGRP neighbor. How many neighbor are there? 2. So this is what full mesh topology. This is full mesh topology. So IP EIGRP neighbor. All routers have 2 neighbor. So IP EIGRP neighbor. This is full mesh topology. If all the sites are directly connected with each other, have the neighborship with each other, that is known as full mesh topology. Full mesh topology is complex to manage as compared to hub and spoke, right? It is easier to configure, troubleshoot. So that's why most of the time, most of the organization, guys, small organizations, large organization, medium sized organizations prefer hub and spoke topology. But full mesh topology is faster as compared to hub and spoke. Now if you will trace 30.1.1.1 means spoke 2 from 20.1.1.1 from spoke 1 numeric. What happened? I am on R1, sorry. From router number 1 I am going to trace router 3 30.1.1.1 and source 20.1.1.1 numeric. Traffic is going directly, yes or no? In hub and spoke also traffic will go directly. Now see, I am going to create hub and spoke topology here. So on router number 1, first of all I am going to remove EIGRP. No router EIGRP S number 10. Again I am saying router EIGRP S number 10. I am going to run command neighbor. What is the neighbor IP address? 192.168.1.2. Right, on which interface? On fast Ethernet 0/0. So guys, after running this command, router 1 will start sending unicast hello message. Unicast hello message. And one more neighbor which is 192.168.1.2. 1.3 on which interface? Fast Ethernet 0/0. Done. So IP EIGRP interface, but EIGRP is not enabled on any interface. Make sure EIGRP is enabled on F0/0 where router will form the neighbor. So router EIGRP ES number 10, I can say network 0.0.0 command. On router number 2, router EIGRP 10 and see do so IP EIGRP neighbor. Now router 2 have only one neighbor, which is router 3. Now here I am going to say neighbor 192.168.1.1 on fast Ethernet 0/0. Now so IP EIGRP neighbor. Now you can see neighborship between router 2 and router 3 has goes down. Now router 2 have only one neighbor, which is router 1, right? Same way on router number 3 we need to configure static neighborship, router EIGRP number 10 and neighbor 192.168.1.1 on fast Ethernet 0/0. So see, so IP EIGRP neighbor, so IP EIGRP neighbor. Done, guys. Now all the spoke sites first see on hub router. So IP EIGRP neighbor, hub router have two neighbor, both spoke like this. If there are 100 sites, so hub router will have neighborship with all the spokes, right? But on spoke branch router, so IP EIGRP neighbor, right? Only hub router is the neighbor of router 2, spoke 1. Same way on spoke 2 R3, so IP EIGRP neighbor, only hub router is neighbor. Correct. Now let's verify the routing table, R1 routing table. So IP route EIGRP. So router 1 is learning all prefixes of spoke 1 branch 1 as well as branch 2 spoke 2. Fine. On router number 2, so IP route EIGRP. Oh, router 2 is only learning headquarter prefix, hub router prefix, right? The subnet which is running in headquarter on hub router. Router 2 is not learning remote site prefix, branch 2 prefix, 30 subnet is not there. Now tell me guys, why router 2 have not received this prefix 30 prefix? Even you can check topology table. So IP EIGRP topology, in topology table also only 10 and directed 20 subnet is there.
Because of split horizon?
Yeah, very good. Because of a split horizon. On router number 1, split horizon is enabled. So on R3 also, so IP route EIGRP, we don't have route, we have only headquarter prefix. So what is happening, guys? These routers, router 2 will advertise these prefixes to router number 1. On this interface, router 1 will receive the prefix, so it will not advertise same prefix from the receiving interface. So this is the reason why router 3 is not learning. Same thing is happening for these prefixes as well. So what is the solution? In this scenario, we should disable the split horizon, and definitely loop will not form. Where loop can form? When your topology is in loop. Here my topology is not in loop, so loop cannot form here. I can disable the split horizon. Go to hub router interface F0/0 and by default IP split horizon for EIGRP number 10. This command is enabled. Simply I can say no to this command. Once I will disable it, you can see EIGRP neighborship is resynchronized, and now again you can check the routing table of spoke 1. Now you can see spoke 1 is learning all 30 prefixes, 30.1.2.0, and soon it will receive, yes, here it is 30.1.1.0. In the same way on router number 3, so IP route EIGRP, it is also learning 20 prefixes. Done. Route EIGRP, headquarter prefix and spoke 2 prefix on router number 3. Now the interesting thing is, See the next hop IP address, guys, for 30 subnets on router number 2 on spoke 1. Next hop IP address is IP address of headquarter. It means whenever these two sides will communicate, they will communicate via hub router headquarter, right? Ping 30.1.1.1 and source 20.1.1.1. Ping is working, both are able to communicate, and trace route 30.1.1.1, source 20.1.1.1. Traffic is going via headquarter, right? But in real time, these sites will be communicating directly with each other via internet. They will only exchange control plane traffic, means routes via the headquarter, because here I don't want to form EIGRP neighborship. So your requirement is all the spoke sites should exchange prefixes via headquarter, but they should communicate directly with each other. So now what I have to tell to hub router R1, I have to tell to router number 1 that brother, whenever you are advertising 20 subnet to router number 3, why you are adding your own next hop IP address? Do not modify the next hop, because when router 2 will generate update message, guys, to advertise these prefixes. See how these sites are going to advertise prefix. Let's say router number 3, router 3 is going to generate one update message. In the update message it will include 30.1.1.0, 30.1.2.0, right? Then it will add IP header. In the IP header, source IP will be exit interface IP address 192.168.1.3, and destination IP will be what? 224.0.0.10 multicast address. It will forward to headquarter router R1. R1 will update their topology table, will update their routing table, and then it will advertise to router number 2. So when router 1 will advertise to router number 2 to spoke 1, it will change the source here. It will set source what? Their on exit interface IP address. So I am going to tell to router 1 that do not change the next hop, as it is advertised to router number 2. So this time router 2 will get what next hop, guys? 1.3, means it can communicate directly with each other. It can communicate directly. So see on router number 1, again by default one command is running on interface F0/0, that is IP next hop self for EIGRP yes number 10. So I am going to disable this command, right? Because of this command only router is modifying the next hop IP address. Now again EIGRP neighborship is resynchronized. Now you can check R2 routing table again. So IP route EIGRP. Now see the next hop IP address for all 30 subnet. 192.168.1.3, right? So now guys, if you will trace route, you can see traffic is going directly. Got it? Any question?
Then sir, if router 1 goes down, then there is no any impact with router 2 and router 3.
Then these spoke sites cannot communicate with each other.
Why sir?
Because how router 2 will learn this 30 subnet then? How these spoke routers are learning prefixes, guys? Via headquarter only, via hub router only. So if hub router bill goes down, then it will not learn 30 subnet, or router 3 will not learn 20 subnet. So prefix will goes down. There will be no
So
route in the routing table.
here sir, we will not use a next hop of router 1.
No, but see, doesn't matter you are using next hop or not. If hub router will goes down, connectivity will goes down. Interface F0/0 shut down. Now these two sides cannot communicate with each other, because EIGRP neighborship will goes down. Yes or no?
Yes, yes.
There is no EIGRP neighborship between R2 and R3. No such, right? So in real time, guys, in headquarter we will have multiple 2 router at least for the backup, right? Here I will have one more router, hub 2, like this, right? And all the spoke router will have 2 EIGRP neighbor, one with hub 1 and one with hub 2. For the redundancy, right? For all the things, like for all the link, for ISP even also, right? We will have redundancy in real time. Single ISP is not sufficient. What if ISP will goes down? So now we are not talking about the redundancy and those things. Just try to understand the EIGRP only. In real time we will have multiple ISP here, right? We can have internet, we can have MPLS, we can have LT, 4G, 5G, we can have broadband. Any other question? Can I close this lab? No. Now let me capture the link. Any link, let's say this link. So IP, EIGRP, neighbor. Again we have neighbor, and again here, so IP, route EIGRP, done. Now guys, on router number 2, I am going to don 20 subnet, 20.1.1.0/24. I'm going to don this subnet 20.1.1.0/24. What will happen? Router 2 will generate query message to their neighbor, to R1, and R1 will forward that query to router number 3, to their neighbor, right? But router 1 should not forward that query to router number 3, right? So we'll configure stub router. Let me show you first the query message here. Interface loopback 1, I'm going to say shutdown. See the query. Source IP address in this query message 192.168.1.2, means router 2 have generated this query message. Why query message is static? Sorry, unicast. Because of unicast neighborship, means static neighborship. In static neighborship, all the messages of EIGRP is going to be unicast only, right? There is no multicast message. Even so IP EIGRP, so IP interface F0/0. So this interface is member of this multicast group, because EIGRP is enabled on this interface, but it will not send any message on multicast address. If it will receive any message, it will accept that, because this interface is part of the multicast group, but it will not send any multicast message to their neighbor, because both neighbors are static neighbor. So that's why this time the query message is unicast. This is also interview questions. When router will send unicast query message in case of static neighborship? When router will send unicast hello message? You can see even all the hello messages are unicast. When router will send unicast update message in case of static neighborship? So guys, router 2 have sent one query message to router number 2. Router 2 sent one query message to router number 2, then router 1 sent acknowledgement, and after that router 1 is sending query to router number 3. Yes or no? See, source is 1.1, destination is 1.3. 1.3. Right? So to avoid this, what we can do, we can configure the stub router. So let me first up the interface. Interface loopback 1, say no set here. Again router will send update message here, and you can see update message is also what? Unicast. Now I'm going to configure this router as stub router. Router EIGRP is number 10. What is the command to configure stub router? Command, can anyone check command to configure stub router?
EIGRP
Not IP.
EIGRP
stub.
Stopped out.
stub. This is the command. On router number 3 also I'm going to say router EIGRP 10 and EIGRP stub. Again I'm going to down loopback 1 interface of router 1. Interface loopback 1 and shut down. See in the caption, topology is stable, fine. Let me set the port. See the query message. 192.168.1.2. Router 2 sent query message to router 1, and this time router 1 is generating directly reply. It is not forwarding the query to router number 3 to spoke 2. This is the benefit of stub. Got it, guys? In the show IP protocol somewhere you can find that this router is stub router, stub. So this router is stub router, is advertising connected and summary prefix only. In the same way router number 3 is also a stub router who is advertising only connected and summary route. So now router 1 is not going to send any query message to a spoke side. It will not forward any query message to a spoke side. Done. Now before starting the filtering, route filtering or path manipulation, we have the last topic, that is variance. So let me close this topology now. And let me open now this topology. Variance. So guys, first of all it is 7 bits decimal value. 7-bit decimal values. So what will be the range? 0 to 2 power 7 means 0 to 2 power 7 means 128. 128. This is the range of variance. Range.
What is the purpose to use variance? Why we use variance?
It is applied, or you can say applicable, only for feasible successor. Feasible successor. It is used to perform unequal cost load balancing. So guys, by default EIGRP perform equal cost load balancing. Equal cost load balancing means if the AD value, metric and prefix length is same, then EIGRP will perform load balancing. But by using variance, we can perform unequal cost load balancing also. Right? Then you can say it is multiplier of FD of successor. It is FD multiplier of successor, right? Means we can multiply whatever variance value you are going to define on router, that will be multiplied with FD of successor. That will be multiplied with FD of successor. Now, dual algorithm, as you know, EIGRP uses dual algorithm for best path selection. So dual will install all path in routing table which has lower value than multiplied value of FD. What it mean? Let me explain you. See, router 1, router 2, router 3 and router 4. One, 2, 3 and 4. Guys, on router number 4 I have one subnet, let's say 10.1.1.0/24, right? Metric on this receiving interface is, let's suppose, 10. Metric on this receiving interface where this network is connected is 10 metric, right? Install this network 10.1.1.0/24 with what metric? 10 on the interface. Metric for this subnet is 10. After that, metric of this link is, let's say, 10. Metric of this link is, let's say, 5. Metric of this link is, let's say, 5, and metric of this link is, let's say, 15. So tell me which path is the successor? Which one is the successor? FD from upper path is 25 and RD from the upper path is 20. Correct? FD from lower path is total distance. 30
30.
and RD 15. So tell me which one is the successor? This one is the successor, right? Best path. Successor. Now, is this lower path feasible successor? Is lower path feasible successor? Yes, because
Yes.
RD is lower than FD of successor. So this path is feasible successor. Successor. Right? So here we can achieve load balancing. See, by default, router 1 is going to install both path in their topology table. 10.1.1.0/24 metric 25 via R2 and 10.1.1.0/24 metric 30 via router number 3 R3. Done. This is topology table. If I will talk about the routing table, in routing table there is only one network. 10.1.1.0/24 reachable via R2. This is topology table and this is routing table. So router is not performing load balancing, but here we can achieve load balancing with the help of variance. See guys, by default variance value on router is 1, right? If I will configure variance value 2, if I will configure variance equals 2, what this router will do? This router will multiply FD of successor by 2 variance value, right? So FD multiply by 2, it means FD is 25 multiply by 2. What value it will get? It will get 50. Now router 1 is going to install all the path in routing table from the topology table who have metric lower than 50. What I am saying, router is going to install a dual algorithm, is going to install all the path in their routing table who have metric lower than or equal to 50. This is what unequal cost load balancing. So this time you can see the metric of lower path is 30, which is lower than 50. That means it will install this path also in routing table. It will install this path also 10.1.1.0/24 via router number 3 R3. Even you will see the metric is not equal. Here metric is 25, here metric is 30, right? So if metric is not equal and router is performing load balancing, that is known as unequal cost load balancing, right? To achieve it, here we can configure the scenario. Just a minute. So from tomorrow we'll see the path manipulation and route filtering. Those are the only left topics in EIGRP. Then guys, we'll start OSPF routing protocol. R2, R3, R4. On router number 1, config T, router EIGRPS number 10 and network 0.0.0. Do so history. Done. I have enabled EIGRP on all the router. I think loopback is not there on R4, so IP interface brief. Yeah, loopback is not there. Let me do one thing from router number 1. So run section loopback. So run include okay, I'm getting like this. Okay, let me do one thing. Let me create it. Interface loopback 1. I'm going to create only one loopback. That is also sufficient. 192.168.1.1.255.255.255.0. Done. Now let me take you to router 1. On router number 1, so IP route EIGRP 192.168.1.0. So IP route EIGRP, let's say. So see, we have this subnet and it is performing load balancing. We can check route in detail like this. You can see the detailed information. So guys, how many next hop is available for this subnet? 2, 13.3 and 12.2. The reason? Equal cost load balancing. Metric is equal from both sides. Right? Now, with the help of offset list, we can add some metric on lower path, or I can change bandwidth and delay as well. Let's say the cost link of all the path is not equal. Here we have this link is Ethernet link, this is the fast Ethernet link, rest all are, let's say, fast Ethernet link. So I'm going to make this interface as Ethernet. Bandwidth I'm going to configure 10. Right? So IP route EIGRP. Now we have only one path, this one. Right? And so IP EIGRP topology. In topology table, how many path? 2 path. So guys, now can anyone tell me what should be the value of variance so that dual algorithm can perform load balancing? What value of variance I should configure here for the unequal cost load balancing? So IP protocol, by default variance value is 1. So it is multiplying FD of successor by 1. Right? It will get same value. So IP EIGRP topology. 2 path is available. Metric from lower path is this one. Metric from lower path is this one. And metric from upper path is this one.
Sorry, excuse me, for route 192.168.1, right? Not for 32, correct?
Okay.
Sorry about that.
Here it is. This one.
Thank you.
Metric, and from lower path, sorry, from the upper path, this is the metric. So guys, tell me, if I will configure variance value 2, will router perform load balancing? If I will configure variance equals 2, then load balancing will happen or not? It will
We
multiply.
can divide, sir.
Sorry?
Sir, we can divide bigger
Yes,
value
very
with
good. We
smaller.
can divide to find the variance value. We can, if you will multiply this value by 2, I think maybe you will get value greater than this value. If you will get lower value than this, then definitely it will not perform load balancing. So the best practice is we can divide this value from this value. I will get the variance value, right? So let me do that. Open calculator. In the calculator, I'm going to 256133 divided by 1587820. What should be the value of variance? This should be the value of variance. Can I configure this value, guys, as a variance? What I told you, what is the range of variance?
0 to 128.
Yes. So can I perform unequal cost load balancing here?
No.
No. Right? So it is not possible that every time you can perform the unequal cost load balancing. There is limitation. See, 1587820 multiply by 128. Maximum value that I can get is this one, which is lower than the FD of feasible successor. So here we can do one thing. Here we can increase some bandwidth. Interface f1/0, and I am going to say bandwidth 99. Right? So interface f0/0 include bandwidth. This is the bandwidth of f0/0 and f1/0. This one. Okay, it is in kbps. So interface f1/0 bandwidth 2440. Now done. Here we have one more 0. So IP EIGRP topology for this subnet. Now this is the FD of successor. This is FD of feasible successor. So your new FD is this one. Now can you tell me, guys, now this time if I will configure variance value 2, will it perform load balancing? Again we can divide. Again I can divide. So this time I am going to divide 389120 divided by 1587202. Variance value should be 3, right? So let me do one thing here. Let me configure variance value 2 first. Do so IP route EIGRP. It is not performing load balancing. Router EIGRP as number 10 and variance 2.
Sir, please 3.
Still it is not performing load
Sir,
balancing.
please 3. You put there number 2, variance 2. Should be 3, please.
Yeah, I am going to configure. I want to show you that if you will configure 2, it will not perform load balancing. Okay?
Thank you.
If I will configure 3, guys, then also it will not, yeah, then it will perform load balancing, right? 3. And now check the routing table. Now you can see. This time you can see the metric is not equal. Metric is unequal. Still router have installed both path in the routing table. This is the feature of EIGRP. Only EIGRP is the routing protocol which can perform unequal cost load balancing. Right? So now we have covered all the topics of EIGRP. Now the things is we need to understand the path manipulation and route filtering. Okay, so IP EIGRP topology metric is different, so IP route EIGRP. It is performing load balancing, right? Trace route 192.168.1.1 and source 10.1.1.1 numeric. From router number 3, why traffic is going from router number 3? This is issue of GNS3. Okay, now it is forwarding traffic from 12.2. Yes, IP load sharing, we can change the load balancing algorithm as well, like per packet or per destination. So by default it is performing load balancing on the basis of per packet, right? We can configure it per destination as well, like for 192.168 or 1.1 it can use upper path, for 2.1 it can use lower path. That is the behavior of router, right? You don't need to learn it now. For now you only need to understand EIGRP, and you can see this time router is performing load balancing. Interface, look back to IP address 192.168.2.1.255.255.255.0, 13.3 and 2.1. Now 2L. Okay, leave it, can ignore it, fine. So guys, we have already covered the offset list also. Like with the help of offset list, what we can do, we can add some metric. We can add some metric on interface. By using access control list, we can classify the traffic, we can specify the traffic, for which traffic you want to add the offset list. After that you can add offset list, right? There is one more concept that we need to learn. Just try to understand one thing. Like if I will guys summarize these all prefixes here on router number 1, if I will summarize these all prefixes, and summary address is 10.1.0.0/16, let's say, right? So now router 1 will advertise it to router number 2. Router 2 will install summary address in routing table, and then it will advertise to router 4. Router 4 will also install it in the routing table. It will advertise to router 3. Router 3 will also install it in routing table, then it will advertise to router number 1. Now again router 1 will receive the summary dot. This can be what? Loop. This is loop. So router 1 will not accept this update message, right? The reason guys, whenever you will summarize, you will perform summarization on router is going to install that prefix in their routing table with null 0 interface. First it will install 10.1.0.0/16, and for this network exit interface is null 0. For summary network it will use AD value 5. There are 3 AD value in EIGRP: 19, 90, 170 and 5. 5 is for summary dot. So when router 3 will advertise this summary address to router number 1, router 3 will advertise with AD value 90, and router 1 have already same prefix with AD value 5, so it will discard it, right? And whenever router will receive traffic for the destination will be match, which will match in this prefix, you can say for that exit interface is null interface, then router is going to drop that traffic. Router is going to drop the traffic, right? So you can verify it here simply on router 1. I can perform summarization interface F0/0. I am saying IP summary address for EIGRPS number 10, and summary address is 10.1.0.0, subnet mask 255.255.0.0, right? So IP route EIGRP. So you can see somewhere here 10.1.0.0/16 is a summary address, exit interface is null 0. So IP route and 10.1.0.0. AD value is, distance is 5, right? So sometime interviewer can ask you when EIGRP route will have AD value 5. So guys, whenever you will perform summarization on router will make one entry for that summary address with null 0 interface, null 0, and AD value for that summary address is going to be 5, right? After the path manipulation we can discuss 190 also, that is external. External means, let's say here guys I am running rerouting protocol. This is the domain where I am running RIP routing protocol, any other routing protocol. It can be RIP, OSPF, BGP, and here EIGRP, right? Let's say this is network of different company. This is network of different company, right? We are connecting network of two different company. So in this scenario, here you are running EIGRP, and here you are running, let's say, RIP. So in this scenario, EIGRP and RIP cannot communicate with each other. RIP EIGRPS number 10. So in this scenario, what will happen? Router 1 will not receive these 192 prefixes, and router 4 will not receive 10 prefixes. The reason? Different routing domain. different routing domain, right? So this interface is in RIP, this interface is in RIP, this interface is in RIP, this interface is in RIP. Router 4 will advertise to router 2, router 3. These interfaces are member of 224.0.0.9 and these interfaces are member of .10 EIGRP, right? So by default prefixes of RIP will not enter in EIGRP and EIGRP prefixes will not enter in RIP, right? So what we need to do here, we need to redistribute RIP into EIGRP and EIGRP into RIP, RIP into EIGRP and EIGRP into RIP. So whenever EIGRP is going to learn RIP prefixes, EIGRP will consider that as external route, right? It is learning from external routing domain, right? So for all the external prefixes, AD value is going to be 190, right? So EIGRP has 3 AD value. One is 5, another one is 9, sorry, not 190, 170. One is 5, one is 90 and another one is 170, right? This is for summary address, this is for internal route, and this is for external route, right? You can consider what you can consider that this is different company, this is different company. You can consider this is another side, this is another side, right? You can consider this is one building, this is another building, right? This is in Delhi, this is in Mumbai, and both are connected with ISP, with two ISP, ISP1 and ISP2 for redundancy, like that. So these are what common scenario. Okay, we'll see it tomorrow in the next class. Now if anyone have question, please ask. EIGRP part 3, which day it is? 9,
10,
10.
9, 9, 9.